So we all know that there are always two ways to name a hydrocarbon. So first is common name and second is IUPAC name, or also called International Union of Pure and Applied Chemistry. So since we're going to tackle about ethers, thiols, and thioethers, let's see how they are named according to their common name and IUPAC name. So first of all, we're going to tackle about ethers. Ethers common name, rule number 1. Name the hydrocarbons bonded with the oxygen atom alphabetically, then separate the words with a space. IUPAC names and nomenclature. Rule number 1, select the longest carbon chain and use it as the base name. Rule number 2, apply the rules in rule number 1, but this time we have to add the prefix di. Alkoxy group, smaller hydrocarbon attachment with the oxygen atom and is considered a substituent. IUPAC names and nomenclature. Rule number 1, select the longest carbon chain and use it as the base name. Rule number 2, change the YL or il ending of the other hydrocarbon group to oxy to obtain the alkoxy group name. Methyl becomes methoxy and ethyl becomes ethoxy, and so on and so forth. Rule number 3, place the alkoxy name with a locator number in front of the base chain. So as what we have discussed earlier about common name and IUPAC name of ether, you can see here that the symmetrical and unsymmetrical examples are shown. So the reason why it is called symmetrical because here you have methyl and also here you have methyl. It is only considered unsymmetrical if what you have on the left side bonded with the oxygen. You can see on the left side methyl and on the right side would be methyl. So I'm sorry, methyl and ethyl. So that is why it is called symmetrical and unsymmetrical. So these are 5 examples and how to name it by applying the rules of IUPAC names and nomenclature. So rule number 1, select the longest carbon chain and use it as the base name. So here we can see that the longest chain is ethyl. So we are going ethane rather. So we are going to use it as our base name or our parent chain. And the substituent would be the lowest number, or the smaller attachment. So to name this, we should start by locating where the oxygen atom is attached. So since it is attached on the first carbon of the parent chain, we have to consider that this is already 1, and on its left side it is the substituent. So again, to name the substituent, we just have to replace il to oxy. So then this becomes methoxyethane without adding number 1. So next up is an example on how to name symmetrical hydrocarbon bonded with oxygen. First, we have to again look for oxygen, and since it is symmetrical, we could use both, or I mean one of the carbon chains that are attached with the oxygen. So since both of them are ethyl, then we only have to choose one. Either way, we will end up with ethoxyethane. So the reason why it is ethoxyethane is because oxygen is attached to the first carbon atom of ethane, and then we are going to consider this on the right side, the carbon chain on the right side as the left side as a substituent already. So again, to name a substituent on ethers, all we have to do is change il to oxy. So here, ethoxyethane. For the last example, this is quite complex because I got an incorrect answer for this because I considered oxygen as part of the parent chain when we have to still look for the parent chain that has carbon and that is a hydrocarbon. And since oxygen doesn't have carbon or either carbon attached to it, the parent chain should be this carbon, first carbon, second carbon, and third. So since there are 3 carbons that are attached to each other or linked with one another, it is called propane. Now to name this compound, again we have to look for the oxygen and where it is attached. So since it is attached to the second carbon from the parent chain, then we have to add a locator number where the oxygen is found. So since it is found on the second carbon chain, we have to put 2 before the substituent methyl. So again, to name the substituent, all we have to do is change il to oxy. And now we have the answer here, 2-methoxypropane. The reason why it is not added or not placed at the center, since oxygen is found between 2 carbon attachments. We always have to put number 2 on where the oxygen and its substituent is found. Last but not the least of the example, what we have right here is ethyl phenyl ether. So ethyl phenyl ether is a common name of this hydrocarbon bonded with oxygen derivative. And to name this, we always have to consider the benzene ring as its base, and the carbon chain, the hydrocarbon becomes the substituent. So the IUPAC name for this example is 1-methoxybenzene. 1-methoxybenzene is the IUPAC name of this example. Next, we're going to discuss the common name and IUPAC name, or just the IUPAC name of the thiol. So we all know that thiols are an organic compound in which a sulfur atom is bonded to a carbon atom and a hydrogen atom. Sulfur analogs of alcohol. Their distinctive physical property of thiols is that they're foul odor. So properties of thiols when compared to alcohol: lower boiling point, higher volatility, lower solubility in water. Thioethers, an organic compound in which a sulfur atom is bonded to two carbon atoms by single bonds. Sulfur analogs of alcohol. So IUPAC nomenclature rules for thiols. Rule number 1. Name the longest carbon chain to which the thiol group SH is attached. As in the case of diols and triols, the E at the end of the alkane name is also retained for thiols. Rule number 2. Number the carbon chain starting at the end nearest the thiol group SH, assigning the lowest number possible to the carbon bearing the thiol group. The thiol group takes precedence over double and triple bonds as well as over alkyl, cycloalkyl, and halogen substituents. Rule number 3. Name and locate any other substituents present on the molecule according to the standard alkane naming rules. Rule number 4. If the thiol group is attached to a carbon atom in a ring, the ring is numbered beginning with the carbon bearing the thiol group. Numbering then proceeds in a clockwise or counterclockwise direction to assign the next substituent the lowest possible number. The number 1 for the thiol bearing carbon is omitted since, by definition, it is considered carbon 1. Rule number 5. A thiol group as a substituent in a molecule is called a mercapto group. The suffix thiol is used to indicate the presence of the substituent. So for example, we have right here on the left, this is pentane, but you can see the hydroxyl attachment on the second carbon from the parent chain. So this is named 2-pentanol, and since alcohol and thiol are named this in the same way, all you have to do is change all to thiol. So here is a list of another set of examples for thiols. So as you can see here, these are all common names, and the reason why it is called propyl mercaptan is because mercaptan is the old name for thiols. So example number 1, all we have to do is look for the first carbon where the sulfur and hydrosulfur is found. So here, this is the first carbon, second carbon down to the last carbon where the hydrosulfur is found. So we will consider this carbon chain as the base, and this would be thiol. So again, thiol would be found at the end of the parent chain. So since this is propyl mercaptan and IUPAC name, this is called 1-propane thiol. So as you can see, 1-propane thiol. I did not put thiol on the first or before the parent chain. It's because this is how it should be named, since it is just the same with alcohol. So this is a isopropyl mercaptan, and to name this, all we have to do again is look for the hydrosulfur and where it is attached. So we have 3 carbons here, and as a whole, this is called again propane. So since this is propane, all we have to do again is to look for the hydrosulfur bond. Hydrosulfur, and we have here the first carbon, second carbon, and third carbon. Now that it is found on the second carbon, this is named 2-propane thiol. So both of these examples are isomers, just that the arrangement of thiol, or the sulfur and hydrogen, is located differently. So next example is cyclohexyl thiol. So it's just named the same way as alkane, as you can remember. It's pretty easy to name a thiol. All you have to do again is to look for the hydrosulfur, and you don't have to add 1 because wherever you put it, whether here at the apex of these hexagon or here, still 1, so don't have to add 1. And again, add cycle first, and then the parent carbon derivative or carbon attachment or carbon chain, whatever. Then all you have to do is again add thiol at the end. That's all. So as you can see on this example, methylphenyl sulfide, which is its common name. Then as per rule naming thioethers, all you have to do is add thio to the alkyl. So methylphenyl sulfide then becomes a methylthiobenzene. The reason why it becomes a methylthio, it's because sulfur is attached to the alkyl methyl. So that is, and again, all we have to do is just add thio to the alkyl methyl, and then benzene as its base. Here we have dimethyl sulfide. The IUPAC name would be methylthiomethane. So again, it's just like naming ethers in symmetrical. So since we both have here methyl and methyl, again we only have to choose one of it to become the base. So we will choose either. Let's say we will choose this hydrocarbon on the left, so methane. And again, we will consider this as a substituent, so methyl. We will have to add thio because of sulfur, so IUPAC name then becomes methyl thiomethane. The reason why we don't have to and also we don't have to add one, we're just going to add a locator number if there are gonna be two sulfurs, or maybe this sulfur is located on the second carbon of a parent chain. Yes. So here a very complex example of thioether. So the reason why I only have 3 examples, it's because it is already the summary of all. So I have here a thioether with a benzene ring, thioether with 2 hydrocarbons, and here a thioether with a double bond. So here, the reason why it is 4-ethyl thio 2-methyl 2-pentene, it is because, again, since we have here the parent chain pentene, so again we have to count here 1, 2, 3, 4, and 5. So that leaves us with pentene, and since the double bond is found on the second carbon, then we have to add 2 before the parent chain. So that's always the rule. There's always the locator number for the double bond, and it's always found before the parent chain. And here, since we have sulfur and its substituents, alkyl group, this is called the alkyl group. And again, all we have to do is just add thio to the alkyl group where the sulfur is found. So sulfur is found on ethyl, so we have to add ethyl thio. And reason why it is 4 here as its locator number, it's because it is found on the 4th carbon from the parent chain. And we will have to continue and look for this substituent, which is an alkyl, and specifically called methyl. And since it is found on the 2nd carbon from the parent chain, then we have to add its locator number. Again, we always have to watch out on how to divide numbers or separate numbers from words, always with a dash if we're going to separate number to words, or vice versa. And if it's going to be number to number, there's always a comma.